This video is about graphing piecewise defined functions, and excuse me, this is an example of a piecewise defined function. And so it's defined in pieces. So the function f of x is equal to x, but it's only equal to x if x is less than or equal to 0. F of x is equal to x plus 2 if x is greater than 0. So you pick which piece of this function you're going to use based on what your x value is. So we're going to take a look at how to graph this, and then we're also going to find the domain and the range of the graph. So the most important thing to do is we're going to graph these in pieces, and instead of using function notation, I'll just use regular equation notation. So we have y equals x. We're going to use this if x is less than or equal to 0. Okay, so that's one piece that we need to graph. And then the other piece that we're going to graph is y equals x plus 2, and we'll be graphing that when x is strictly greater than 0. Okay, so we're going to do these each separately, and so this value right here is the most important point that you'll need to know. So that's where you stop using this piece of the function at x equals 0, and you switch to using this piece. And so you need to know where that stopping and starting point is. And so we're going to put 0 into this to find a point. So if x is equal to 0, then y is equal to 0. So we get the point 0, 0. This has an equal sign for x equals 0, and so this gets a solid dot at the point 0, 0. So put a solid dot at the point 0, 0. And then we want, so you pick your x values according to this interval. So this says x has to be less than 0, so we want to pick something less than 0. You can pick whatever you want. Negative 10, negative 5. I would pick something that's going to fit on the graph, of course, though. So I'm going to pick x is equal to negative 2. So you can pick any number you want as long as it's something less than 0 according to this interval right here. Okay, so if x is equal to negative 2, then we would have y is equal to negative 2 because y equals x for this piece. So that gives me the point negative 2, negative 2. So negative 2, negative 2 is the point right here. And is all you need to plot for a line is 2 points. 2 points defines a line, and so we can go ahead and draw this piece of the graph in already. So it's this line. Now we're going to move on to graphing the other piece, and so again we need 2 points. You need to know where you start using this piece, so you need to put 0 into this equation. Even though it's not really defined at x equals 0, you still need to plug 0 in for x. So I'll use an arrow instead of an equal sign because x can actually be equal to 0. Then y would be 0 plus 2 or 2. Oops. Not 0, 2. And so we would have the point 0, 2. And because x can't really be equal to 0, this gets an open dot. Because this doesn't have an equal sign. This one has an equal sign, so at 0, 0 we had a solid point. This one does not have an equal sign, and so it gets an open dot. And so that was at 0, 2. We have an open circle there because x can't actually be equal to 0. So we indicate that with an open dot. X can be equal to 0 down here, though. We need one other point so that we can finish graphing this second piece to our function. And so again, you use this interval. You want to pick some value of x that's bigger than 0 because that's when we're using this piece. So I'm going to choose x to be equal to 2. So then y would be equal to 2 plus 2, or 4. And so I have the point 2, 4. And the only dots that you need to worry about being solid or filled is at this point, 0. Okay, any other points are going to all be filled in. So I have the point 2, 4. And now we have 2 points, and so we can go ahead and draw this piece of the graph in as well. Okay, so here is a picture of our graph. And very important that you label all of your points, and again that you have these arrows on there. You should need to make sure that you have your arrows on there. And we want to find both the domain and the range. Again, remember the domain are the x values, and so it's where is their graph on the x-axis. So if we could shine a light on the graph. So you kind of have to think about from above and below because we have graph up and top. But if you're looking at the x-axis, so there's graph way off to the left over here, and there's also graph way off to the right. One place that you might have to worry about it is this place right here. There is graph at x equals 0 and anything after that. So basically it's going to be negative infinity to infinity. And we'll do the range in green. So the range were the y values, so where is their graph along the y-axis? And so I like to look at the bottom. And so if you could shine a light over, we would be casting a shadow. This goes down forever, so the shadow would go down at negative infinity. And how far up would it go? Well, we'd have some shadow until we got to right here, and then right here there wouldn't be any shadow. So the shadow would stop at 0. It would shine on 0 though, so we put a square bracket there. And then you need to join these two sets together, and we do that with this big capital U. It's called the union symbol. And then we pick up right here again at y equals 2. But we use a round bracket there because this open circle indicates that it does not really include that value. So we start back up at 2 again, and then this goes up forever, and so our domain or our range would go up forever as well, so up to positive infinity. In our next example, f of x equals 4x plus 3, and that's if x is less than or equal to 1, and f of x equals 1/3 x minus 2 if x is greater than 1. Okay, so we're going to do this in 2 pieces. We have y equals 4x plus 3, and that's going to be for x is less than or equal to 1. And the second piece of this is y equals 1/3 x minus 2, and this is good for x is greater than 1. So let's graph our first piece, and again we need to put this value, whatever it happens to be, in. So we need to find, we need to let x be equal to 1. Then y would be equal to 4 times 1 plus 3. And that's 7, so we have the point 1, 7. Excuse me, and this is a solid dot. So at 1, 7 we have a solid dot. And then we need to find one other point, and this is for x is less than or equal to 1, so pick something smaller than 1. So I would like to move a little bit away from 1, so I'm going to let x be equal to negative 1. So we would have y is equal to 4 times negative 1 plus 3, and that's negative 4 plus 3, which is negative 1. So I have a point at negative 1, negative 1. That's all the way down there. And we only need 2 points to define our line, so we can go ahead and draw our line in. And then we need to graph the second piece. So for this one, again, you need to put this 1 into there because we need to know when we're going to be starting to use this piece. So if x is 1, then what would we get for y? We would get 1/3 times 1 minus 2. And so that's 1/3. We need to convert this to thirds. 2/3 is the same as 6/3. And so we would get negative 5/3. And negative 5/3 is the same as negative 1 2/3. Okay, so we have this point 1 and negative 1 2/3. And you could also make this into a decimal. It's just that negative 5/3 really doesn't make a whole lot of sense to me. I need either a decimal or a mixed number to put on my graph. So I have the point positive 1 and negative 1 2/3. So that would be about right there. Oops, and this should not be a filled in dot. This should be an open dot right here. And it's open because there's no equal sign with the x equals 1 here. So we're going to use this piece when x is bigger than 1. So now pick a number that's bigger than 1. And I'm going to pick my number carefully because I have a fraction here. Excuse me, and I don't want to end up with fractions when I'm doing my calculations like I did in this one. I had to do this one, and so I put up with the fractions, but when I get to choose my own x values, I'm going to choose something that's going to give me nice numbers. So I'm going to choose x equals 3 because then when I do this multiplication, I'll get an integer. So I'll have y is equal to 1/3 times 3 minus 2. And 1/3 times 3 is 1, so I get 1 minus 2 or negative 1. So this gives me the point 3 negative 1. So here's the point 3 negative 1. And label this point is the point 1 negative 1 2/3. And then we can go ahead and draw that piece of the graph in. Okay, so there's our graph, and then we want to find the domain and the range. And remember, the domain are the x values. This is going off to the left forever. This goes off to the right forever. So we have negative infinity. And we have graph until we get to x equals 1. And so it stops here, but it picks right back up. And so this graph goes from negative infinity to infinity. And then we also need the range. So let's get the range in here. And the range, remember, are the y values for a function. And so if we look down, this graph goes down forever. And so that would be negative infinity. And we have graph, there's graph, all the way up until we get to right here. And that's where the graph stops. Well, but does it really stop? This piece actually goes up forever. And so our graph actually goes up forever. And so it's going to be positive infinity to infinity. So be careful of that. That will fool me a lot of times when I'm doing these, is that I forget to look at this little piece down here. But since this goes up forever, then even though this one stops, this one's going to continue going up forever. And so the range is really negative infinity to infinity. Yeah, it looks like we have 2 more of these. So this next one, so we'll do the same thing. And you can go ahead and pause the video and give this a try on your own. And then start the video back up after you get it and see if you got your answer correct. Okay, so we're going to graph the 2 lines, y equals x plus 2. And we're going to graph that piece for x is less than 0. And we also have y equals negative x plus 2, and that piece is for x is greater than or equal to 0. So we need 2 points for each of these. Remember to put this point in to both of them. And so when x is equal to 0, we get y equals 0 plus 2, or 2. And so that gives us the point 0, 2. This does not have the equal sign at 0, and so this is open. So at 0, 2, we have an open dot. Now I need to pick another x value. Use this interval to select it. We want something that's less than 0, so I'm going to pick negative 2. So we'll get y is equal to negative 2 plus 2, which is 0. So I have the point negative 2, 0. And don't forget to label your points. And as all we need is those 2 points in order to draw our graph in. So again, here we need to put this value x equals 0 in. So we'll get y is equal to negative 0 plus 2. Negative 0 is the same as 0, so we just get 2. So we have a point at 0, 2, and this is filled in, or we can say solid. And so we have a solid dot at the point 0, 2. And now I need to pick another x value, pick it according to this interval, so we want something bigger than 0. So I'm going to pick 2. We would get y is equal to negative 2 plus 2, which is 0, so that gives me the point, not 0, 2, 2, 0. So x equals 2, y equals 0 right there. And then we can draw that piece in. Okay, so we get this capital V shaped graph. Now we want the domain. Again, the domain are the x values. So this graph goes off to the left forever. It also goes off to the right forever because of these arrows. So that would be negative infinity to infinity. And there's graph everywhere in the middle as well. And then the range are the y values, and so this graph goes down forever, so we'll pick green to do range, I guess. And so this graph goes down forever, because these arrows go down forever, so that's negative infinity. But the graph stops right here at 2, and it does include 2, because we did have a filled-in dot there, so 2 and a square bracket. Okay. Okay, so this one is a little bit different than the ones that we've seen before. So our first piece of this graph is y equals negative 2. And so this is a line. It's just a special type of line, and it's a horizontal line. And we're going to use that when x is less than or equal to 0. And for the other piece, this is y equals 2, which is also a horizontal line. And we're going to use that when x is greater than or equal to 1. So for sure we need to, oops, I gotta switch back to red. So for sure we need to put x equals 0 in there. But this is y equals negative 2 is a horizontal line, so no matter what x is, y is always going to be negative 2. So y is always negative 2. So we have the point 0, negative 2, and because this has an equal sign at 0, this is going to be solid. Excuse me. And then we need to pick some other value of x that's less than 0, so I'll pick x equals negative 2. And this is, again, a horizontal line, so y is always negative 2. So we have the point negative 2, negative 2. So we have 0, negative 2, and that was solid. And we have negative 2, negative 2, also solid. And it's just a horizontal line. Then the other piece we'll be doing in blue. So this, again, is a horizontal line, and we want to make sure that we have x equals 1. Then y is going to be 2. And it's solid because this has an equal sign. Okay, and then use this interval, so it's x is greater than 1, so we have to pick some value of x that's bigger than 1. I'll pick 3. And y is always 2 for this one, so we have the point 3, 2. And so here's our graph, and again we want to do the domain and the range. Remember, domain are the x values, so if we're shining a light down or up, where are we going to end up with shadow? So this goes on to the left forever, so our domain goes on forever, and we have graph all the way until we get up to 0 right here. And then there's no graph, but it starts back up at 1 and goes on forever. So we have negative infinity up to 0, including 0, so a square bracket, union a square bracket, because we're including 1 here, and it goes on up to positive infinity. And then we need the range. So when we go down here, there's no graph. There's only two places where there is actually a graph, at y equals -2 and y equals +2. And when your range or domain are single values like that, we always put it in a set instead of as an interval, because we're listing single values. So y can be -2 or +2 and no other values. So we're listing single values here. These are intervals, including, so this is every value between negative infinity up to 0. Okay. All right, that's the end of this lecture. Let me know if you have any questions.